I'm going to go ahead and open a program called VS Code, Visual Studio Code, which is a free program that we use in CS50 more generally that allows me to write code on my Mac or PC or in really any internet-based device. And I can actually write code and not only write it, but run it. And I'm going to write code in this case in a language called Python. And this is just a very popular language, but I could use any of a dozen or more different programming languages. And the goal here is not to learn Python. For that, we have whole other classes. But to just demonstrate what an adversary, what a hacker need do if they want to get into, for instance, your iPhone or Android device or anything that has just a 4-digit password. Now, my presumption here for demonstration's sake is that I'm going to go ahead and write code that just prints all possible passwords on the screen. But you could imagine if I had a USB cable or maybe a lightning cable, I could connect this phone to this laptop, especially if it's your phone that I just swiped from a table, could quickly plug it into my computer here, run the code that I'm about to write, and maybe automatically send all 10,000 possibilities to your device before you even realize the phone is gone. I'm going to go ahead and in a text file called crack.py, where crack is actually a term of art. It just means to figure out what a password is, to brute force your way in. Now, there's a bunch of different ways I can write this code, but what I really want to do intuitively is try all possible digits for the first value, try all possible digits for the second, then for the third, then for the fourth. So in just a moment, we're going to see, is it going to take a few minutes, a few milliseconds, a day, 4 hours, or here we go. 1, 2, 3, go. OK. So those of you who estimated just a few milliseconds were spot on. So what's the takeaway here? Well, apparently using a 4-digit password is not very secure at all, because look how quickly I, the adversary, the hacker in the story, was able to get into your phone. And in fact, I could probably unplug it at that point because I've gotten whatever data I care about off your phone, and you might not be none the wiser. So how can we go about improving upon this system? Well, let me propose that instead of using a 4-digit passcode, let's use 4 letters instead. And we'll use English because that's what I speak well. And in English, we have 26 letters of the alphabet, A through Z. But you know what? That might give us initially 26 possibilities for the first position, times 26 times 26 times 26 for the second through fourth. But let me propose that we actually use lowercase and uppercase letters. So that gives me not 26, but 52 possibilities for each location. So if I do 52 possibilities, that's 52 to the 4th power. And does anyone want to estimate how many possible passwords there are if I'm using 4 English letters now, uppercase or lower? But here we have estimates along the lines of, indeed, 7 million as well. So with 7 million possibilities, you might think, OK, surely that's going to be a lot better, and it's going to take the adversary a lot longer to hack into this phone. But let's try that. Let's go ahead and open up that same terminal window. Let's run Python of crack.py. And here now is the answer to how long might it take an adversary to get into your phone if you're using 4 letters of the English alphabet for your password instead. OK, so this time I have enough time to walk all the way over to the screen here. And you can see that we're going in alphabetical order. First lowercase, now uppercase. But in just a moment, we are done. And we're down all the way to Z, 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 Z. So that was a few seconds, which is indeed slower. But that really wasn't that much effort at all. So presumably then even 4 letters of the alphabet might not be enough to keep us secure. So let me go ahead and do what we all are told to do anyway, which is to go into your phone or whatever device in question and actually use 4 characters perhaps instead. So not just letters, not just digits, but let's toss in some punctuation as well. And in the world of punctuation, at least on a US English keyboard, there's typically as many as 94 possibilities for letters, numbers, and punctuation, because we have 26 lowercase letters, 26 uppercase letters, 10 decimal digits, 0 through 9, and another 32 punctuation symbols that we can add into the mix as well. So that gives me 94 possible keys that I can hit here, or 94 to the 4th power. And does anyone want to estimate what this is? Seeing it indeed in the chat, roughly 78 million possibilities. So in some sense, 10 times more secure. I'm going to open up my terminal window again. I'm going to run Python of crack.py. And this time, because we have 10 times as many possibilities, I kind of had 10 times the amount of time to walk over to the screen, because indeed we're still in the lowercase e's, f's, g's, H's. And now it looks a bit like a Hollywood movie, maybe. You can perhaps see, even though it's going across the screen fast, that there's a lot of cryptic output here because we're running through all of the letters, the digits, and the punctuation. So it looks a little fancy at that. Now, you might recall, too, from Hollywood movies, too, that they tend to be very dramatic. And so instead of just doing this, which is iterating from left to right very slowly, the movies and TV shows tend to very dramatically get like the third character right, then the first character right, then the fourth character right, and then just in time, you get the second one as well. Like, that's not really how brute force works. You tend to do things methodically, not jumping around from symbol to symbol. But this is clearly taking a long time, and I'm not even going to finish waiting for this to go because we still have to get through all the punctuation. So this is to say ultimately that 78 million possibilities is actually getting up there pretty fast. But honestly, if we come back in like a minute or so, I bet that will be finished nonetheless. And none of us, hopefully, has a password that's only 4 characters nowadays. Letters, numbers, and punctuation. Odds are it's at least a conventional 8 characters. And indeed, most websites and apps require as much of you as well. Now, the math here is pretty straightforward, too. If you have 94 possibilities, but you have 8 characters in total now that's 94 to the 8th power. And does anyone want to ballpark just how many passwords are possible if it's only 8 characters, which isn't even that long? Too much to count. OK, I see that we've given up here. But I did see one in the chat. It's roughly this many possible passwords, which is actually a little hard to figure out. So this is, let's see, millions, billions, trillions, quadrillion. So this is 6 quadrillion possibilities. So now we're talking. Now the adversary is probably going to run out of time, run out of energy, run out of money, run out of lifetime if it's going to take this much time to try to crack, so to speak, your particular password. And so here's one of our first takeaways when it comes to cybersecurity and securing our accounts. It really is this game of relativity and resources. What we're really doing here is not something fundamentally different by adding in digits and numbers, digits and letters and punctuation. It's sort of still the same formula, the same approach to our passwords. But as we add complexity and as we make it longer and longer, we're raising the bar to the adversary. Why? Well, so long as you and I don't do something dumb like still choose 0, 0, 0, 0, 0, 0, 0, 0, so long as we're choosing something that's pretty random in that range of 6 quadrillion possibilities, it's going to take the adversary way more time than it would otherwise to brute force their way into that password. And so by the time they finally get into the account, you might have changed the password already. You might not be using the account anymore, or you or the adversary might not even be on this planet anymore. And that's indeed the goal. But there is a downside, of course. The longer your password gets and the more complicated it gets, the more likely you and I are to not even be able to remember what that password is. And so here is that sort of balancing act, trying to figure out this balance between the usability of the account, just how user-friendly it is to access, versus the security of that account. And finding that inflection point is somewhat personal or somewhat corporate in policy typically.